Question 1, given the graph to the right, they're actually saying the graph below, identify the solution to the system of equations. Well, we know that a system of equations has a solution where they cross. And if you look at these two lines here, they're parallel. And since they do not cross, guess what? They do not have a solution. There is no solution to question 1. 2, given the graph to the right, identify the solution to the system. So we're trying to find out where do they cross. Well, it looks to me like they're going to cross out here somewhere. We need to extend these lines out. So let's extend this guy out a little bit. And let's extend this guy out a little bit. And you can see right here is where they're crossing. So this is the point we're looking for. To find that coordinate, we're going to go along the x-axis from the origin. So you go 1, 2 to the right, and then we'll go up 1. So the solution is 2, 1. 3, determine the type of solution for the following system. So we need to figure out, remember there's only 3 types of solutions. There's a system that has one solution, and we're talking about, of course, in Algebra 1, what we've been discussing. There is a possibility for no solution. We don't do 2 solutions in Algebra 1. And then we have one that's infinitely many solutions. Well, these guys right here are already in y equals. Let's put them in y equals in the calculator, and let's see which one of these 3 best fits the graph. And if you look right here, it does look like they cross. And where they cross, so you have a line like this and a line like this, they cross at 1 point. That means they have one solution. So our answer is A. Number 4, identify the solution to the given system. So we said a solution is where 2 lines cross each other. Where they cross each other, that is where they share the same coordinate. Let's see if we can find a matching set of coordinates here. 1, 5, we can't match that up with 1, 5. 2, 6, I don't see any other 2, 6s. I don't see any other 3, 7s or 4, 8s, but if you look here, I see a 5, 9 and a 5, 9. That is our solution. Number 5, just like the same question from number 4, identify the solution to the system. Well, if you look here, 1, 3 matches up with 1, 3. 2, 6 matches up with 2, 6. 3, 9, 3, 9. 4, 12, 4, 12. And in fact, we know that it's not just one answer. No solution means there wouldn't be a match. And we said that if we have more than one matching, in this case 1, 2, 3, 4, it looks like if we were to extend this table out and continue this pattern, we would have 2 tables that are the same, which means we have the same graph. They cross everywhere. There's infinitely many solutions. 6, which of the following graphs best represents a system that has no solutions? It does not cross. Well, we know this guy crosses here, so it's not B. If we extend this guy out a little bit right here, we know it's going to cross somewhere up here. We know it's not C. A might look parallel, but it's not. This one's kind of canted in a little bit, and if you were to draw those guys way out here, you would say they'd cross way over there. So we know it's not A. In fact, D has 2 parallel lines. Our answer is D. 7, solve the system. To solve it means we need to figure out where do they cross. What is that coordinate? What are the missing x and y values that make up the coordinate? Oh yay, they're both in y equals. We're going to use our y equals button. I have them typed in the calculator. We are going to hit graph. Let's see if we see anything here. It looks like it crosses way up here somewhere, right? So I'll show you 2 different ways to do this here. The first way is we're going to use the table. So second table. Let's use our coordinates here and see if we find matching sets of y's. If I go to -6, 30, oh look, -6, 30, -6, 30. In fact, that is my answer right there. The other way to do this from the graph is, since you can't see the intersection, we're going to zoom out. So you're going to hit zoom. Out is number 3, but you have to hit enter. The calculator hasn't zoomed out. Let's see if we can see where they cross. Now I can see that they cross way over there. There's something called calc. Second, we're going to calculate, guess what? An intersection, number 5. And then all you have to do is get your blinking cursor where you think the intersection is and just hit enter, enter, enter. And guess what? It gives me the x value of -6 and a y value of 30. Our answer is A. 8, just like number 7, except this time they want to know what is the y value of the solution. Well, we know that the solution is where the two lines cross. And where the two lines cross, it makes a coordinate. And to make a coordinate, you have an x value and you have a y value. This time they're asking what is the y value to the answer. Let's get these guys in y equals in the calculator since they're ready to go for us. 2x plus 1, -x plus 7. Let's graph. You're going to notice the graph is zoomed out still. But what I want to do is I want to set it back to a standard window. So zoom, look at number 6, standard. It'll get it back to the way you're used to seeing it. So the two ways, let's review the two ways. The first way is let's go to the table and see where the y's match. So see if we have matching y's here. Let's see. Well, we can use our answer choices. Let's see if we have matching y's over here at -5. Do we have matching y's at -5? No. Wrong. +2. Do we have matching y's? No, well, it doesn't look like we have a 2. Do we have a -2? Do we have a 5? Oh yeah, look right here. So we know our coordinate is 2, 5. This is where it crosses, or this is the solution. We can also do second calc number 5. Get it close. Enter, enter, enter. It'll give you the coordinates 2, 5. But it's asking what is the y value to the solution. Well, the y value to this answer is 5. Be careful, because if you misread the question, you might think that they're asking for the x. Nope, they're asking for the y value. Number 9, you'll notice that in number 9, they are not in y equals. If these equations are not in y equals, you cannot use the y equals button. So you have two options. You can put these both in y equals, or since they give me the x and y coordinate values, the inputs and outputs, I can actually store those. So let's start with letter A right here. Let's take 1 and store it to x. And let's take 6 and store it to the letter y. Now what we're going to do is we're going to type in this guy right here and see if we get an answer of 5. -x plus y. Do we get an answer of 5? Yes, that works. But that must also work here. We must type this in and see if we get an answer of -9. That's when we know if we have a solution or not. X minus 5 alpha y. Let's see if we get -9. We do not get -9. So it did not work for the second one. And did not work. So we know A is not an answer. So let's try letter B here. So we're going to type or store 4 to x and 1 to y. The good thing about using these TI-84s, I don't have to type these two equations in. They've already been data logged. So I'm going to go up to the first one, -x plus y. I can hit enter, it'll copy it. Hit enter again, I get a value of -3. I need a value of 5. Goodbye, that's not going to work. Let's go down to letter C. Let's stow these guys here in the calculator. -6, store to x. -1, store to y. Go back up. Here was our first one. Hit enter, it'll copy it, paste. We get 5, yes, so we got a match. But we have to get a match for the second one. Let's try to find x. Where's x minus 5y? Come on. There it is, x minus 5y. We copy that, and then we hit enter, and we get a value of -9. No bueno. So we assume that our last answer is D, but let's go through and let's actually prove that. -4, stow to x. We're going to store this to x, store this to y. 1, store to y. Let's copy our first equation we typed in, -x plus y. We'll copy and paste. We get an answer of 5, yes. Let's copy and paste our second one. We need to get an answer of -9. If we do, yes, we do. Bingo, there is our answer. Now you can do The other method, I call it the paper method, to where you could take each one of these guys here. We'll take this guy first. If I have, let's move this calculator over. Negative x plus y equals 5. Split it up and move the negative x. That's positive, positive. Y equals x plus 5. We'll put that guy in our little cloud. See, it's in y equals. Now we need to get this other guy in y equals here. So we'll just use this, split it up, move the x to the other side. It becomes minus, minus. And this would be negative x minus 9. And then you can divide everything by negative 5, divide this by negative 5, and divide this by negative 5. You get y equals a negative 1 divided by a negative 5 is a positive 1 over 5th, or 1 over 5x. A negative 9 divided by a negative 5 is a positive 9 over 5. You could use double negatives here if you wanted to in the calculator. I'm just showing you how to clean that up algebraically. Let's grab our calculator here and let's type these two clouds in y equals, because now they're ready to go. We have them typed in y equals. Let's go to our table. We said our answer was negative 4, 1. Let's see if we have a match at negative 4, 1. Yes, we do. Negative 4, 1, negative 4, 1. There's our answer. You could also do second calc, intersect number 5. Let's see if it intersects at negative 4, 1. Instead of using second calc, you could actually just take your cursor. I'm going to quit. I'll show you a little different way. You can just take your cursor and just get it close to where you think the intersection is. Well, it looks like it's close to negative 4 point something, and it looks like it's close to 0.9. Well, negative 4 point something is close to negative 4. 0.9 is close to 1. So there's another way that you can see that intersection there. 10. Solve the given system. It is not in y equals, which means I cannot use my y equals button. So I'm going to use stow. We'll start with our first coordinate here, 3, 8. 3 store to x, 8 stow to y. Let's type in this, we'll call this the green guy. Let's type in the green guy. X plus 2 alpha y. Let's see if we get a value of 0. We do not get a value of 0. Goodbye, 3, 8. Let's type in 8, 3, or stow 8, 3. So 8 goes for x, 3 goes for y. Let's type in our green equation, x plus 2y. Let's see if we get a value of 0. And we don't get a value of 0, which means this is not an answer. So what do we do now? We're down, I guess we could guess, no solution or infinitely many solutions. At this point, we don't have any more coordinates to test, so we're going to have to put this guy in y equals. So let's put this in y equals here. Let's x plus 2y equals nothing. Bring the x over to the other side. That's negative x. I'm not going to do negative x plus 0 because that's just negative x. And then my last step is divide by 2, divide by 2. I can put my invisible 1 there. That would be negative 1/2 x. Okay, let's try this guy here. We'll call it the little pink equation. This is just a one step, divide by 8. Divide by 8. Well, guess what? Negative 4 divided by 8 is negative 1/2. These are the same equations. But the question is, if these are the same equations, well, what is that going to look like when we graph them? How many lines are you going to see? Let's try this here. I'm just going to use negative 0.5. I don't want to use the fraction key. Negative 0.5x, that's the same as negative 1/2. Negative 0.5x. Let's see how many lines we see. There's one, and we don't see another one. How come we don't see the other one? Because they're both the same. They're both on top of each other. So you have this pink line, and you have this green line. And we said that the solution is where they cross. They're crossing everywhere, which means they have infinitely many solutions. But some of you might be saying, well, if these have infinitely many solutions, how come these two answer choices weren't part of the infinite solution set? Because they're not on the line. Only the coordinates that are on the line are the infinitely many solutions. Not an infinite meaning that every solution that exists, only the solutions that are on the line. So our answer is D. 11, solve the system here. We're looking for where they cross. Oh yay, we already have 1 in y equals. We might as well just go ahead and do this one. Put this in y equals. It's going to take 1 step to move it to the other side. It becomes negative. So that's in y equals. This is in y equals. Oh look, if you look right here, you'll notice that the slopes are the same, but they have 2 different y-intercepts. I wonder what that's going to give us. Let's type it in the calculator and see what happens here. Negative 2x plus 5, and then we have negative 2x minus 6. Let's graph it. The solution is where they cross. It looks to me like we have 2 parallel lines. And we could prove that by going through a process of elimination. Let's go to our table. Let's look at this first coordinate. Does negative 2, 5, do we have a match here? Nope. How about 2, negative 6? Do I have 2, negative 6 here? Nope. Infinitely many solutions means you have 2 lines that are on top of each other. Those do not look like 2 lines on top of each other. In fact, they're parallel. There's no solution. Let's look at 12 here. Find the x value. So they're asking for the x value of the solution. Now remember, a solution to a system is where they cross, and where they cross creates a coordinate. And we're trying to figure out what is the x value of that solution. This guy right here is already in y equals. We're good to go. So what we need to do is put the other one in y equals. So 3x minus 2y equals 14. Let's move the x to the other side by doing opposites. We're going to subtract. So that gives you negative 3x. The 14 is positive. And bring down the negative 2y. And our last step is to divide everything by negative 2. That's supposed to be a negative right there. So then you're left with y equals negative 3 over negative 2x plus 14 over negative 2. Now I could go through and I could clean this up here. Negative 3 divided by negative 2, that's a positive. But a positive 14 divided by negative 2, that's a negative. That would give you negative 7. Now we have them both in y equals. We can use the y equals button. So we're going to go into y equals here. Negative 6x plus 18, that's this guy. 3 over 2x minus 7. Here, ready? Let's go. We're going to do second calc. This time we're going to do 5, the intersection. We're going to get it close and then go enter, enter, enter. It's asking for the x value of the solution. The x value of the solution is 3.3 repeating. That means it's not B. It's not C. It's positive. That means it's not D. So our answer is A. You have to use second calc, number 5, in order to get the x value, or what you would have to do is you could just take your cursor and just get it close to the intersection and go, okay, it looks like the x value is about 3.4. Well, which one of these answer choices would be positive 3.4 or close to that? It'd still be A. It's not going to show up in the table because if you look right here, your table is counting by ones, and these answers here are specifically A, that is a fractional amount, so that's not going to show up in the table. 13, solve the system. Okay, so they're not in y equals. I can't use the y equals button, but they give me both x and y. So I'm going to stow this problem here. Take negative 0.5, we're going to stow that to x. Take 0 and store that to y. Let's type in our first equation right here and see if we get a value of negative 2. 4x minus 7y. Do we get a value of negative 2? Yes. But the condition also has to be true for the next one. Let's type in 12x minus 21y. Do we get a value of negative 42? No. So we know it's not A. Let's try letter B. So 0 goes for x. 2 over 7 is going to go for y. So 2/7. Store that to y. We're going to copy and paste our equations here. So there's the first one. Let's see if we get a value of negative 2. Yes, that works. But we need to get a value of negative 42 for the other one. Let's go to the second. There it is. Copy and paste. Do we get negative 42? No. Okay, so now we have to figure out, is this all solutions or is this no solutions? So in this case, you're going to have to put it in y equals to determine that. Let's put this guy right here into y equals, so 4x minus 7y equals -2. We'll split this up. Start moving the x first. So we're going to do the move divide. So we're going to move -4x. The 2 is minus. Bring down the -7. And then our last step is to divide by what's in front of y. But you have to divide everything in front of y. Let's clean this up. Negative divided by a negative is a positive. Negative divided by a negative is a positive. There is our first equation in y equals. Let's get the second one in y equals here. So we're going to move the 12x by doing opposites. Goodbye. Minus 12x. Minus 12x. The 42 is negative. Bring down the -21. Y. Our last step is to divide. So let's divide by -21. -21. -21. Let's do some housekeeping here. Y equals negative divided by a negative is going to give me a positive fraction. We can reduce that. So let's divide this, both of these parts here by 3. 12 divided by 3 is 4. 21 divided by 3 is 7. These two guys are negative, which means at the very end they're going to be positive. And let's do some housekeeping here. What two numbers can we use? Oh, it looks like we can use 21. 21 goes into 42 twice, and then 21 goes into 21 once, but we're not going to put the 1 there. So now we have our two different equations. Looking at our two different equations, you should be able to determine that the slopes are the same, but they have two different y-intercepts. So if they have two different y-intercepts, that means this guy is going through +2, 1, 2, and it has a slope of up 4/7, something like this. And then we have this guy here. Its y-intercept is 2/7. That's just barely above 0, and it goes up 4, and it has the same slope. And when you have the same slope but different y-intercepts, they are parallel, which means this guy has no solution. 14, the second of two numbers. So we have two numbers. We have a number x and we have a number y. We'll say this is the first number, and we'll call this guy the second number. You can pick any letter you want, but since they're using x and y in the problem, that's what I'm going to use. So the second number, y, equals 4 more than the first. So that's 4 plus the first. So here's our first equation from the system. Let's keep reading and get our second one. The sum of the numbers, so that means if I take x plus y, equals 56. Here's our second equation. And it looks like our answer is B. I will tell you that C is also a correct answer, because look at this guy right here. If I took x equals y minus 4, and I rewrote it as y minus 4 equals x, and I decided I wanted to move the 4 to the other side, I would do opposites, wouldn't I? Well, it looks like that equation is the same as the one we have right here. So really there are two answers to this equation, B or C. 15, the number of calories in pecan pie. We're going to use the letter P for pecan pie. So the number of calories, so P means equal, 20 less than. Less than means, I'll give you a kid-friendly definition here, to subtract backwards. Do not do this. 20 less than 3 times the calories of ice cream. Less than means it's a switch word, which means you need to switch these two guys around. So really it's going to be written as P equals 3i minus 20. This is incorrect. That is minus. Less than means to take away from something. So this is our first equation that we have from the system. Let's keep reading here. Pie and ice cream. So that means if I add them together, pie plus ice cream together, have means equals 500 calories. This is our second equation. So let's match things up here. We know it's not A because they did not do less than there. Goodbye. And in fact, it looks like our answer is C. 16, one wall inside a shoe store is used to display walking shoes and running shoes. So we have two types of shoes. We have W for walking, and we'll use R for running here. There are 135 pairs of shoes. So if I were to just make a little total cloud, there are 135 total shoes together. There are 1.5 times as many pairs of walking shoes as there are running shoes. So that means walking shoes is more than running. Running shoes have to be less because they're telling you that the walking shoes are 1.5 times as many as running. So we have to go 1.5 times the running. So let's go through and do a process of elimination. Looks like this is more. That could be a possibility. This 54 is less than 81. That's not going to work. 45 is less than 90. That's not going to work. 81 is greater than 54. That's a possibility. So now all we're going to do is we're just going to take the running shoes here, multiply it times 1.5, and see if we get the amount of walking shoes. So let's do that here. 45 times 1.5. Does that give me 90? No. Let's try this here. 54 times 1.5. Is that going to give me 81 walking shoes? Yes, it will. There's our answer, D. And 17, a candy company sells blah, 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 blah. How many cases? Let's just get down to the question. How many cases? Well, here are the cases. So it's asking how many cases of chocolate bars will this company need to sell in order for the costs to be equal? Well, where costs and revenue are equal, we're looking for this part of the system here, where they cross each other. We're going to need to extend some lines out. So let's see if I can do this here. We're going to extend this guy out here. And let's extend this guy out here. So we're looking for where they cross. Looks like they cross right here. The question's asking how many cases is that? Well, let's extend our x-axis out. And let's pull a line down here. And let's try to figure out, we're going to see if we can get pretty close here. How many cases does this number represent? So it looks like they're counting by 0.5, 3, 3.5, 4, 4.5, 5, 5.5, 6. So it looks like it's almost 6,000, and I'm sure my increments are off a little bit, but 6,000 is the only one that is reasonable, and it's in thousands. So our answer is B.